Jai Hind. Myself Dr. Aditya Pratap Singh, Associate Professor, IT Department, Ajay Kumar Garg Engineering College. In the series of lectures on C programming, the topic array and pointers, today we will go with the part 2. In previous session, we have completed the introduction of arrays. So, let us quickly refresh what was array. Array is a collection of homogeneous data types or the homogeneous values. Whenever we would like to have multiple values of similar type like x1, x2, x3, x4, or we have a collection of like for example height of students, then in that situation we need to store, either we will store in individual variables or we can create an array of that type, like we can store height in an array of type float. So that was the basic concept of array. So array is a ordered set of homogeneous values stored in contiguous memory location. So this arrays, how they are stored in memory, that we have already discussed in part 1. Today in the part 2 we will start from the beginning of how to implement those arrays in the C programming language. So this is the syntax for initializing and declaring an array. For example, first we will have type. If we are not giving storage class, then by default storage class will be auto, and here we will give type. So storage class is optional, we can leave it, that will be taken as auto, or we can create different storage classes. Then the name of the array, what like any identifier for variable, all the rules of simple variable identifiers will be applied to the name of array also. Then the size of array, this size tells the compiler that what number of values we can store, how many elements we can store in this array, and what size it will occupy in the memory while executing. So this size will give information for how many memory blocks will be reserved. For example, in this example we have taken integer marks. So marks, that is like here we have given size as 5. It is of type integer. So in standard compilers the size of integer variable is 4 bytes. So 4 bytes, and how many elements are there? 5. So 4 into 5, that means 20 bytes will be reserved. 20 bytes will be reserved in the memory, and these 20 bytes will store the elements 72, 83, 65, 80, 76. These values will be stored in memory location, 4 bytes each. So this is how we are declaring and initializing arrays. This is the syntax for declaring cum initializing an array. In the previous lecture, we have also seen that we can declare like int AR10 like this also. So here we are only reserving a contiguous memory location that will be of, so 4 into 10, that will be of 40 bytes. This will be stored in memory, but the values are not available. So there will be random values or garbage values available as an element. But here what we have done, we have also supplied the values. So array is created as well as initialized. In another example, we have taken character data type, name, and number of elements are 4. So we have taken 4 character AMIT. So we have stored these 4 characters into memory. So how many, what will be the size of this array? I hope you can calculate. Like how many elements are there? 4, and per element size requirement, it is a character. So that will be 1. Number of elements 4. So this will be 4 bytes. So we have different techniques for initializing arrays. Like we can create only an array without any value, that will be garbage or default or garbage values. We can create arrays by providing or supplying the values also, so that array is created and initialized both. Whenever we supply a value while declaring an array, then remaining values will be 0, that we will discuss in coming slides. Another special case, when if the number of values in the list is less than the number of elements. For example, here we have taken float total 5. So the size of array is 5, but we have provided 1, 2, 3. We have provided only 3 values. So in this situation, what will happen? The first 3 elements, so at index 0, at index 1 and at index 2, these values will be initialized. Remaining values will be 0.0, 0.0. So that is now total 1, 2, 3, 4, 5. So that means, please have attention. It is a critical information that whenever we are supplying even one value to the compiler at the time of declaration, in this situation, the remaining elements of the array will be set to default values or zeros. Zeros, like for numeric values, it will be 0, and for character value, it will be null character. So, like I hope you are clear. When we are supplying some values, like this is an array of size 1, 2, 3, 4, 5, 6, 7. So like we can have character n size is 7, and we are also supplying a value a, but only one value. I have supplied only one value. In this situation, what will happen? Here a will be stored, but remaining elements are not being supplied at the time of declaration, but we have supplied one value. So remaining values will be \0, that is null character. So all these values will be null character. So they will be default. In this situation, we have, that is very clear. You need to keep this in mind. Sometimes such kind of questions are also asked in Viva or interviews during your placements also, that what will be the output of type of questions. So you need to have a clear understanding that whenever we have not supplied any value, then the initialized value will be a random value or garbage value. But if we have supplied at least one value to the array at the time of declaration, in that situation, these remaining values of that array will be default values or will be zeros. 0 means numeric value will be 0 and character value will be null character. Okay, so let's move on. If the size declared is less than the element, then that we have already discussed, then in that initialization, then exceeds will be ignored. That means if the size is 5, but we have declared 1, 2, 3, 4, 5 and 6 elements. Size is 5, but we have supplied 6 values. So in this situation, the remaining or the additional values will be ignored. These 5 will be taken at index 0, index 1, index 2, index 3, index 4, and this 0.4 will be ignored. If the size of array is omitted during initialization of array, then the compiler will automatically allocate enough space to initialize the supplied elements. Like in this example, we have taken a int flag array and we have not taken any size. We have supplied some values that we want to use in this array. So to accommodate this array, this flag value will be 1, 2, 3, 4. So size 4 size will be allocated. That means 4 into 5 is equal to 20 bytes will be allocated for accommodating these supplied values. So size will be automatically set. There will not be any case where the array is declared but the size is not available. Like for example, I am declaring int m1. So this is wrong. There will be error from the compiler because we have not supplied any size. Why such kind of error occurs? Let's understand it. Whenever we are declaring an array without giving it size, so in that situation, compiler will not be able to reserve any memory space. It does not know what space is required as we have not given the required size. But if we have given the required values, then in that case, compiler will automatically understand that these 4 values are passed. That means for integer values, 20 bytes are required. So size of array will be set to 4 and 20 bytes will be stored and these values will be initialized into that. I hope you understand. The array cannot shrink or expand once the size is defined. For example, in this example flag, compiler has fixed the size 4, but in the coming statements, we want to have size 6. So that we cannot do. In case of array data structures, once the size is fixed, after that the size cannot be altered or size cannot be changed. That will not grow or expand. So this is the shortcoming or disadvantage of array. For that purpose, different languages provide different data structures where we can grow or shrink. In C also there is a provision for doing so, but with the help of pointers and dynamic memory allocation that we will discuss in coming lectures. Okay, so let's have a very simple example to understand how arrays can be utilized in C program. So here we have taken like a array named as values of type integer and size we have taken as 10. So you can understand how much memory it has reserved. 4 into 10, that is 40 bytes it will reserve in the memory. We have taken one more variable index. Then we can initialize the values after declaration also. For example, at first position I want to have value 197. At index 2 I am storing -100. At index 5 I am storing 350. So these are the way to access a particular element, or we can say to access an element of an array, we need to have array name and subscript. So here subscript is 2. So we are fetching, or we are referring to the location at index 2 and storing a value -100. So here we can do operations like this also. Value 3 is equal to value 0 plus value 5. So what will happen? To store a value at index 3, it will calculate the value 0. We have taken 197. So 197 plus values 5. So in that situation, here we have value 5 is 350. So 350 will be, so addition of these will be stored in at location 3 or at index 3. For value at index 9, we have performed value at index 5 divided by 10. We can perform operations like this also, increment, decrement, just by accessing the array element. So to access now, there is a operation called traversal. So traversal operation can be carried out using a for loop. We are accessing each element of that array. So we will have a loop ranging from index 0 to, as the last index is n minus 1, so less than 10. And for every iteration, we are incrementing the value by 1. And we are just printing the values. So these values will be like here, you can see value 0 is 197, value 1 is 32671, because we have not initialized value 1. So it is what? It is a garbage value. We have not initialized it. Or what is this? It is a random value. Value 2 we have initialized to -101. Value 3 we have calculated value 3 by value 0 plus values 5, 197 plus 350. So that addition is 547. Value 4 we have not initialized. So it is also a garbage value or random value. 5 we have initialized, 356 we have not initialized. So it is also a garbage value. So now I hope you are able to understand that if we are not initializing an array at the time of declaration, in that situation, when we are using that array, we can also supply values to particular index value. But if we are not initializing all the elements, then in that situation, the remaining elements will have a garbage or random value. So this is a very simple example how we can create an array, how we can supply the values, or how we can manipulate these elements, and how we can traverse all the element of an array. So traversal we are doing with the help of a for loop. We can use while loop, we can use any loop construct to traverse the each element of an array. So here is also another example. Here we have declared an array A10. We have some variables for our use during the program. So here what we are doing, we are reading values from user. So if I want to read each element from user, in that situation I'll have a loop. So we are reading array elements from the user, and like for example, this is one kind of algorithm that we can use to find the minimum element of that array. So we have taken minimum as a some larger value, and that we are not going to have from user. So we have taken a larger value, 99,999. Now we are comparing the each element with the minimum. If minimum is lower than the array element ai, so we are starting from 0 location up to less than 10 location. So we are traversing each element of an array and we are comparing this with the minimum. If minimum is greater or ai is less than the minimum, then what we should do? We should set the ai value to minimum. So ith index value will be stored in minimum, and when we come out of loop, we will have the minimum value in that array available in the element min. So that another way of doing the similar thing is this, like rather than giving a largest value, what we can have, we should start by having, or we can take as like a 0. We have taken the first element as minimum element. We have taken the first element as minimum element, and we can start our loop from 1. So I let the first element be the minimum element that we have taken here, and after that we are comparing this element with each element of the array, and if we found any element smaller than that, we are storing that in min, and finally we are printing the min. So that is another way of doing this. Such kind of algorithms we have discussed in problem solving lecture. So there are, as we already know, that there are n number of solutions available for each problem. We can have different kind of solutions. What solution is optimized for us, that we utilize in our program. So like here, as we cannot grow or shrink the size of array, what we can do, we can use a macro like has defined size 10. So we have used a macro size, and we have given here 10, and we are performing our program using this size. For example, like later we want to have a different size. For example, I want to have 100 elements and then want to find out the minimum. Then in that situation, we need to only change this line. We will change has defined size 100, and this program will be valid for 100. So we can do like this also. Or in the new compilers, what we can do, first we can take the size from user, and later on we declare an array that is of that size. That in coming examples we will use like that also. So this we can perform. Another example, define an array of large size and use only the required number of elements. But this will waste some memory. Like we have taken here 100, but we have taken number of elements from user, and we have used that number of elements only. So this is not an optimized solution. This example I have given, but this is not a optimized solution. What we need to do here, what is happening? If n is 2 less than the 100, then in that situation remaining elements will be wastage all the time. That memory will be waste memory. So what we need to do, either we can go for macros if we have changing requirement later, or the best thing which I find is first take number of elements and then initialize. Like here we can initialize int a n. We have already initialized the value of n. We have taken the from the user number of elements, and then after that we are declaring int a n. So the size of the array will be what user wants. That will be the optimized solution. So we can do this like this in larger problem solving approaches also. Now define an array of required size and use only the necessary number of elements. So that is what I was talking, and here you can clearly see that first we have taken number of elements from the user and then we declared the array. So that is the optimized solution that we have already seen. So that's all for today. In the coming lectures, we will cover up some good programs that we can do with the help of arrays, and after that we will move on how pointers are being utilized to manipulate or to access arrays more efficiently. Thank you very much. Jai Hind.